Hello student, today we will do the practical of meter bridge and the aim of this practical is to find the resistance of a given wire using a meter bridge and hence determine the specific resistance of its material. What are the apparatus required? The apparatus are meter bridge, a wire about 1 meter long of a material whose specific resistance is to be determined, a resistance box, a rheostat, galvanometer, a jockey, one-way key, a cell or battery eliminator, thick connecting wire, sandpaper and screw gauge. What is the theory oblique formula used in meter bridge? In the meter bridge, simple you can say this is based on the condition of the balanced Wheatstone bridge principle. And in a meter bridge there are 4 resistors PQ, R and S are connected and a galvanometer is connected. When the galvanometer shows 0 deflection, then you can say the null point is obtained, and this is called the balanced condition. This is called the balance, and the length is called balancing length. This is the diagram of the meter bridge circuit. You can see the diagram. This in the diagram, meter bridge, one end of the meter bridge is connected with the positive terminal and the another end of the meter bridge is connected with the key, and the meter bridge is connected also with the resistance box and the unknown resistance wire S, and one end of the end of the meter bridge is connected with galvanometer and the another end of the galvanometer is connected with jockey. You can slide the jockey in this experiment and then you can find out the null point. So this is the theory. This is the observation table. In observation table, when we will do the practical, then you can fill this observation table, and the result of the meter bridge, the unknown resistance of the given resistance wire you can calculate, and the specific resistance using the formula rho is equal to SA upon L, you can calculate the specific resistance also. Rest we will do in the practical.
As we have discussed earlier in the slides, now I am explaining the apparatus of meter bridge experiment one by one. This is the meter bridge, and the length of the meter bridge is, this is 1 meter, and you know what is the meaning of meter here? Meter is the measurement, not meter is the 1 meter. So this is the meter bridge and length is the 1 meter, and there you can see here these are the metallic strips. This is the galvanometer which shows the deflection in the meter bridge, small deflection in the meter bridge. This is the resistance box you can take. This is the battery eliminator, and this one is called the jockey. This is the sliding key also, and this is the unknown resistance. This is the unknown resistance. Now I am explaining the circuit. First of all, this end of the meter bridge is connected with the key. This is the key, one-way key, and the one-way key is connected with the negative terminal of the battery eliminator. This end of the meter bridge is connected with the one end of the resistance box, and this end is also connected with the one end of the resistance box. The middle end of the meter bridge is connected with the galvanometer, and one end of the galvanometer is connected with the jockey, and the unknown resistance of the wire is connected with these end of the meter bridge. This is the circuit diagram, and this circuit diagram as I have already explained in the slides, so you can check from there. Now how is it proceed? So first of all, switch on the battery eliminator and kept the voltage at the 2 volt or 4 volt as it is required. Now this is the first, that Now first of all, take out the resistance, a small resistance like 2 ohm from the here, and then we slide the jockey on the wire of the meter bridge, and this is made of the nichrome, eureka, or constantan or manganese. Now the one-way key is, this key is pressed on the one-way key, and now the circuit is complete. And first of all, check the galvanometer shows the reflection or not. See, this is in left direction. This will be in right direction. So it means circuit is correct. Now you find the zero deflection in the galvanometer. You can just slide the now you can find the zero deflection in the galvanometer. And this is the point where the galvanometer shows no deflection. Now calculate the reading from the one end of the positive or negative terminal. Even you can take from here 0 to this one, or from 0 to this one. So the reading of the galvanometer is at, this is around 73 centimeter. So from one end of the galvanometer, this is 73 centimeter, and the another end of the galvanometer, this is 27 centimeter. Generally, the galvanometer shows a deflection in between the 50 and the 60 centimeter. So now the reading is the 73 centimeter from one end of the terminal. So put the values in the given observation table. First one is the L, and second one is the 100 minus L, and then you can find the unknown resistance as given in the slide. Thank you.